tried it a little bit different this time and had everybody send in their questions ahead of time so that we could maybe accompany a few of the answers with some images and charts that may be helpful, as well as just try to make it a little more efficient. One thing I'll ask now, so I don't forget, is we're also kind of thinking of possibly doing a couple different times for future ones so that other people, we have a lot of people from other countries that also like to join in, trying to make more time zone friendly options for those people that are, you know, several hours different than we are. But if anybody has a day or time that would work better for any reason, we're trying to gather everybody's input for our future Dome talks so that we can try to accompany as many people as possible. And with that, I guess we can just jump into the first question. Dennis, unless you had anything you wanted to start with before we got right into the questions.
One of the things that we talked about is to change next week due to some other conflicts, but also with the idea of changing it a little earlier to help some people in Europe or on either coast for that matter. We're looking at Thursday next week at 4:30 is the date we're going to try, which is January 7th, Thursday at 4:30. There will be an email going out tomorrow to everybody on our email list, and if you've got one, obviously you got one before, you'll get a new one. So that's part of what we're trying, is to change up a day and change up a time and see who's available, or maybe basically to offer that maybe once a month or something. We're trying this once a week. It seems to be consistent for the number of people that we get and are interested. So as long as that's up, we're going to continue trying each week. It may get to be that we've saturated the market. I don't know. But we'll certainly get some information to you, let you know what's going on. One of the first questions that we have is, this is from Mark Wilt. And Mark, what I'm understanding is you're looking at dome venting at the top and the bottom, or asking about dome venting at the top and the bottom of the cupola. And we have that. Reinke shakes is what you were looking at building with. And Reinke shakes are an aluminum shake. I brought some samples of them. They're basically a piece of aluminum that's got ribs in it. I'm going to hold it to you sideways so you can see there's very narrow ribs in there. There's the surface painted on one side. It's a Kynar finish. We did a test for them that's Energy Star rated. So there's a color. This is the white. This is a reddish brown. And this is a green that they've got. Holding it up to the light to kind of let you see the reflection of it. It's more expensive than asphalt shingles, but it's forever. Asphalt shingles that we use are the Malarkey brand, noisy shingles. It's the Malarkey brand, and that's a 50-year shingle, Malarkey Legacy. Legacy is the model number. We ventilate the dome in certain climates, and there are certainly some differences in different parts of the country from a ventilation standpoint. Carrie, you can throw that map up. Might be catching you off guard here, but we got a map of there's 7 different zones in the US. And with that, we change the dome in different areas as far as venting or non-venting. So you can see on this map, Mark is out in Pennsylvania. So it depends on what part of Pennsylvania. Most of it's in zone 5A. We are located in Minnesota right on the border of 6A and 7A. And the A and the B with that black line that runs sort of down the middle vertically of the states, the A zone is moist. We have a moist climate. The B zone is dry. Now, I should say to you, and there's a line that you see here, which is really a page that I taped together, and one page was lighter than the other. But it sort of shows what's happened over the last 10 years. The line, the dry line has moved east, almost to where that shaded line is. It's about 150 miles. That's the movement that we've had from dry to wet. So the same thing with these zones. This map, I know, is got to be 15 years old, 20 years old maybe. But it's still being used, still hasn't been changed. But when I look at it, I tend to move those lines north because that's what's happening. We're not getting as heavy of a winter as we normally would. So there's some reasons why California is so dry. So all of this relates to what do we do in those different zones. Our big thing way back in the 80s is we solved the issue with condensation by ventilating our domes. We take air in at the bottom of the dome with a special vent skirt that goes around that dome. And there's air intakes at that point. And at the top of this dome, there is either, if you don't have a view cupola on top, you have what we call our vent cupola on top. It's a cover that goes over the top of the dome. So do we want to ventilate domes down in zone 3A? No, we don't. And especially 2A, and what you don't see is the very southern tip of Florida, which is 1. It's Dade County, where Miami is. Those are very moist climates. We don't want to take air in that's moist and run it through the insulation and then try to ventilate it out. It also relates to vapor barriers. Air barriers, vapor barriers, water barriers, they're different. So all of this discussion really revolves around where do you live? And then another part of it is how do you live? How do you live? Do you turn that air conditioning on and you live with that for most of the summer? That's going to create some other issues. And with that, you need a special kind of vapor barrier. So it's all those things that relate to that. We're going to have the other part of this question that Mark had was, how do you calculate what is needed for either heating or cooling? And then that relates to this area here. Where are you living? His question also was, is there a dome calculator? He sees heat loss calculations for conventional housing, but he doesn't see one for domes. There is one. Basically, we created this from the longhand, I'll call it the long version of Minnesota's heat loss calculation back from the 80s, and have carried it through. So that's where you're going to have about an hour and a half to 2.5 hours of dealing with all of these charts and maps. This is part of the International Residential Code that you're looking at on the screen right now. It shows what the ceiling R value is required right now in these different zones. What we use is we add 11 to that R value. Where were we in 73? How much insulation did we require? And along came the oil crisis and things changed. So we were ahead of that when we started out. We said, oh, we got to create more insulation. We got to get a thicker wall. So in the 80s, we created very thick walls. We went to 12-inch walls and 15-inch walls. And then they changed it again. So we went to 18-inch thick walls in some areas, a lot of areas, as our basis. And we're looking for, and in that most of your zones, 4, 5, and 6, and 7, and 8, 8's up in Alaska, it's an R60. That's what we're looking for. That's what you want to stay ahead of. You want to stay ahead of the curve here. If you design and build your house to meet these requirements, and you'll hear me, some of you heard me say, if you've been with me before talking to me, you just built the worst house you can build because you followed the code. And that's what it is. The code is a minimum, and you want to be above that minimum. You want to stay above that minimum. You want to bank on the future, not the past. So that's where it'll say an R30 down in Miami-Dade County, or go into Texas and the whole southern part of the southern states, and you're at R38. We say you should be at R49 in those bottom states, those southern states. The rest of the country should be at an R60. There's other issues that pertain to this. It's the air tightness in the house. Sort of gets into a long discussion that I'm going to cut off kind of to get into our other questions. But the calculation that we do is we have to look at, slide that up a little bit, Carrie, and you can see the chart on the bottom. It lists the U value. And the U value is the inverse of the R value. So it's 1 divided by R gives you the U value. And that's just another way that they're rating these things. The higher the R value, the better it is at resistance to heat transfer. The U value is the inverse of that. You want a lower number. The big thing that you have noticed if you bought windows, there's a U value that's on your windows. That's the most common thing that you see, but everything has a U value and an R value. So we're looking at what do you have that's making up that dome. We've gone to a lot more hybrid insulation systems where we use foam insulation and fiberglass. And with that, we can do a little bit thinner wall or get more R value in that same thickness, 12-inch, 15-inch, and go to 18-inch if you're really looking at getting an R70 or R75. That's the hybrid system. We can get to that very easily. So we need to know how you're building it, where you're building it, what materials are you using, all these things that are into this thing. And it'll vary. I know later on there's another question relating to insulation and how much insulation should you have and what's the difference when you add insulation. With our system, we have a 12-inch thick wall, 15-inch, 18-inch, 21-inch thick wall. There's no additional cost in the structure to do that thicker wall. What it is there's a plywood gusset. I know, I just realized my prop here is not here right now. So that other question that relates to it is how do you get this insulation level up to where you should be? So it just adds more insulation. Insulation's fairly cheap, easy to do. So we just make a thicker wall, no cost in the structure, and it's just the insulation cost.
Right.
Mark, is that kind of what you wanted to know? The law?
Yeah. Yeah, I think you got it. I don't know if you guys can hear me or not, but
Yep.
Yes, we can. Yep.
okay.
Yep.
Thanks, Dennis.
All right, good.
Well, here I got a quick, easy one for you, Dennis, for the next one from Philip in New Zealand. Looking for suppliers there for stainless steel bolts and moonwood, which I believe you were saying is actually for golf clubs. That's our understanding of it, but stainless steel bolts, I think, is something you could help them out with. So,
Yeah, I looked up Moonwood, and the first thing that came up for like 2 pages of the Google search was the golf clubs called Moonwood, where the brand is. So we can't help them with where a supplier is for that. But if you're on an island, if you're in Nova Scotia, New Zealand, you're on the coast, we're going to use stainless steel nuts and bolts. We have that readily available. We stock it actually here. So if you're looking for that, we also have our components are already, this is our sleeve that we have. It's got a black anodized finish, not anodized, to say the word for aluminum, epoxy coated finish on this. So this is the steel component. And when we're in the coastal region, we take the hub, which is an aluminum hub. This is our hub system. And we put a Duranotic finish on it. So this is stopping the pitting on the aluminum, and the epoxy stops the galvanic reaction happening to the regular aluminum, so you don't have anything happening. So coastal regions need both of those. And yeah, there's an extra cost for the hub. Our sleeves with the epoxy coating is standard. We were doing a double zinc coating for many years, and then we changed it to the epoxy, and there was very little difference because of the cost of just putting a coating on it to start with. So that was really what I think Phil wanted to know down there. So when you order a system from us, again, we're designing it for where you're located. We're looking at the components to match it to what you're going to do. And you may or may not be venting it. If you're in a coastal region, you're not going to vent it, but you still want your parts to be either anodized or epoxy coated.
right, or stainless steel. Okay. Our next question is from Sean from the United Kingdom. He had kind of 3 questions. It looks like he was inquiring about a 10-meter diameter dome at 4 frequencies, guttering for water runoff, and best way to anchor it to the ground, or kind of his 3 questions from Sean.
We've changed sizes and frequencies for several people that just want to do something. We're going to look at a 4-frequency dome, and I won't go into the long discussion of frequency. It's the number of triangles that are dividing up your dome. So the geometry changes. So if he wants to do a 10-meter dome, which is a 32, 33-foot diameter dome, and do a 4-frequency, the panels are going to be much smaller because he's going to have to do that, and that means he's doing maybe a mid-profile dome, which is the equator of the dome. He's got 250 triangles to divide up that geometry. Instead of what we use would be 160 triangles in the same dome size. So you can see the triangles have to get much smaller if you got 250 compared to 160. So it can be done. It's going to raise the cost on the connectors, the metal bracketing system that we use, because you've got a lot more parts and pieces. But if you want that for whatever reason, we've done it. We have limits on our geometry. So we have a certain geometry there for 20 to 29-foot diameter domes, 30 to 40-foot diameter domes we switch, and then 42 to 51-foot diameter domes we switch to the 4-frequency, and then at 56 or 54 to 60-foot diameter we're on 5-frequency. And we'll do a 6-frequency dome, which brings us up to about 74 feet. In all those domes, the longest edge length is going to be about 8 feet. There's 2 of them that go to 9 feet, but that's about it. The rest of them, the longest edge length is 8 feet. Guttering on a dome, we've got it on our dome here, custom made. We made our own gutters. I don't have a good photo of it, but it fits into and kind of hidden along the bottom edge of the triangles. So the rain runoff is coming down the shingles, down the side of your dome, and falls into that gutter. Our other complex that we have, we put gutters on that because we were seeing erosion, stopping erosion control, erosion down the hillside that goes to the creek that we have. So we use gutters. They certainly are going to help you keep the water away from your dome. Easy to put on, easy to clean because they're not 12, 15 feet up in the air. They're right at this level of the bottom of the triangles, which sometimes is 3 feet off the ground.
Right. And then his last,
What's the other question?
his last question was about anchoring to the ground. And I thought you had a couple of anchors that you brought in.
Yeah, Carrie, if you want to throw that photo up of the dome sitting up on metal posts, Doug Peterson's dome. Down in Iowa, there it is right there. These are called helical piers, or anchors if you want to call them anchors. And it is a steel tube that goes down in the ground, and helical means that they've got I'll call it a thread, a fin that sticks out on the bottom part of the dome. And they actually twist these units into the ground. We're talking 10, 12. We used them on my daughter's remodeling, and it was soft soil. And those we used 18-foot long piers to get down to good soil. In this case, Mark was in a really mild flood area. And so this is down in Iowa, but it's near a flood area by a river. And he wanted to be up above that entirely. So they came along and plotted out where all these posts go in the corners. And there's one more slide that shows more of the floor system being put on, and built his dome on top of it. This one happened to be a 36-foot diameter dome. So this gets anchored down. Carrie, if you want to switch to the others, there's two other slides related to this. One is that shows you more of the framing going on, but it's sitting on top of those posts. So there's one more slide that shows how you connect the post to the framing. And that's this anchor. So it's welded to the steel post, and it's then bolted into the floor system. There's another piece going off to the right of this that you don't see, but it's a situation where you want to connect those posts structurally to the floor joist system. So I don't know if Sean is online right now. He's part of the group? He may not be. We have other concerns in anchoring the dome down. It's anchoring the dome down to this floor structure that you see on the screen. So we have hold down brackets. You can turn those photos off and switch me on full screen. This is a hold down bracket. It's a standard piece made by Simpson Strong Tie. It's got screw holes in it. You get the screws that fit into it. There's different versions. Stand back a little bit. So this is an HDU 4. This is an HDU 9, I believe. I should look at the label here. 8 or 9. So if you need something that's much stronger, earthquake zone, we'd use this. In a tornado, hurricane zone, we probably would use this. Depends on the zone that you're in. These go on every corner. They are attached to the foundation with a threaded rod. The threaded rod goes up through here. There's a bracket in here. It fits down over it. And then you put a nut on right here. So this goes down to your foundation. So now you're tying the corner of the dome down to the foundation. Is that foundation one floor down? Is there a lower level on your dome? It may be, but this then might go down to that foundation all the way down. So the threaded rod could be 8 foot high. Where do you need this? Like I said, high wind zones. We're recommending them more in the inland areas from tornadoes and hurricanes along the coast. So this is part of our system when you're in that area. We sell it with this is a package that we put together for you to do this. Normally, you're going to have an anchor bolt that goes into the bottom plate of your riser wall, and it's tied down to the concrete slab if you don't have a basement. You've got a concrete slab. So now you're going to put this anchor bolt in. This is a fancy anchor bolt with a bottom end on it. Simpson makes this one also. So this goes into the concrete, and you put that washer on the top and the nut on it, and you tie this sill plate down to your floor, down to your concrete slab. But if you're using those round cut washers, they're only, inch in diameter. They're really not going to hold much. What's really required, what you've got to have, is an anchor plate. This is called a bearing plate washer. It's 3/16 or 1/4 inch thick steel. They make two different kinds. This fits over as your washer. So now you see you've got a lot more area. These are 3 inch by 3 inch. 75 millimeters by 75 millimeters. You're dealing with something that's strong. They make them this size so that it takes the load and spreads it out over that plate that you've got on the bottom of the dome. So the understanding here is that you need these. You should not be using the little cut washers. You can buy these at Home Depot. Sometimes they don't know what they are because they've never seen them before. But in reality, you go to Home Depot and Lowe's and tell them to look in their catalog, in their list of stuff that they have, and they'll find these. They're used on the West Coast all the time for earthquake zones. But they're beginning to be used more often all around. There's other ways to do this. You can actually put an anchor bolt down and embed this in the concrete and use a 2-part epoxy. Variety of things that we have. But believe me, we know how to tie the dome down and how to tie it down for your design in your area for what your wind speed is.
Okay. All right. I got Paul from California. His question kind of revolves around once you have some land. So his question starts off by saying he's making the assumption that flat property is the best for pretty much any structure. But what should he look for in a property that makes dome building less complicated? And then he asks that when he does have the property, does he make an appointment with you with the dimensions and slope, road access points, views, etc., in order for you to help design the dome to maximize the property he would have. So, and that's Paul from California. And Paul, if you're on too, and you want to jump in and elaborate on that question, or anybody wants to elaborate on their questions, feel free to jump in. We kind of want a little bit of interaction with people if we're missing your question somehow or misinterpreting what you're asking. So feel free.
Yeah, you really want us to know the property that you're building on. You want to know the slope. That's all usually readily available. Just this afternoon, I was dealing with some clients, and I want to see a Google map I want to see what that says. A lot of times there's a map available that's got contours already on it, and you don't have to do a special contour survey. A couple different clients that we've got that have that. It's U.S. Geological Survey map. Tells you what the contours are. We need to see that. We need to know where your view is, where the terrain is sloping, the prevailing winds, all those different kinds of things that relate to that site plan. And it does have a bearing on designing that dome, building that dome, all these different things relate to that. You want to site this, you're gonna have a bank of windows. There's some windows for view windows. We have this large bank of windows that we have here. There's 9 triangles in this grouping of skylights. That's our creek down the hill. So down below here, we have 3-foot high windows that are below these windows. We're looking out those windows at the view. So we made sure that this house was turned to face that view, because if you're off, you know, you're going to buy these windows and they're going to fit a certain way. You can't rotate the dome very easily. So you want to get it right when you're designing it. What was the first part of the question?
He was wondering if there was a certain type of property that would be more conducive to a less complicated dome build.
One of my answers would be to that, to have an access to that building site that a semi-truck can bring your dome down to. Now, you may not have the best site if it's flat and level, there's no trees. You think, oh, it's great for building, but it's not very interesting. So if you find that interesting site, hillside or something else, and you can't get a semi-truck down, that's how your dome kit is delivered, then you need to find an available parking area somewhere at a school, a shopping center, or something, someplace else where a semi-truck can offload, and then you take it from there on truck and pickup truck and trailer and bring it to your site to get it there. So really, yeah, it's nice to build on a flat ground. You can make it flat, but at a certain point, you're going to have on a slope site, you're going to have to deal with a crawl space, which is more money, or a full basement if it's a really steep slope, and that's even more money. So the best way to build is, yes, a flat site, but is it interesting? Can be. Ours is flat. We got a 30-foot drop off the edge here down to the creek. It makes a nice sledding hill in the wintertime going down to the creek.
All right, our next question is from Carl.
Sure.
Oh. What's that, Carrie?
Hi, this is Paul. Can you hear me?
Yes, we can, Paul.
Okay, yeah, I was just kind of wondering, in that question is just, you know, at what point in time do I get involved with the design process? Sounds like it's even before you purchase your dome, before you even have a concept of what you really want.
Yeah, sometimes people are looking at it from the standpoint of deciding what kind of dome they want before they even have the property. But from a design standpoint, we need to know what you've got, what you want. And sometimes it takes the site being bought and you own it. So now you design around that site. And
okay,
you need a set of plans to start out with. We do plans, preliminary stage of plans. And if you go back to the dome consulting page that we have, that we created, there's a really good little description there of the planning process. What happens? Preliminary plans, construction plans, building permit plans, which are really construction plans. So yeah, you want to back this up. I know there's some other questions in here from a timeline standpoint. How long does it take to design? Well, it's a matter of how many changes you're going to make. we suggest that you allow yourself 3 to 4 months from a planning standpoint. If you're looking at, oh, gee, I'm going to design this and then jump right into it, sometimes doesn't work that well. You need some time. You need to bring that plan out to your property, lay it down on the property and say, gee, where does it face? Take the plan, oh, there's my living room. What does it face? Oh, that faces that way. Oh, gee, that just turned the garage and made it face this way. But the entrance is over here. So you got to have a relationship there that you want to make sure it's the right relationship to fit your property.
Okay.
Can I ask a question?
Sure.
You're kind of talking about one of the things I've been debating, because our property is several states away.
Okay.
It's gonna be a few months before we get there. When does the builder and Natural Space Domes, when do they start talking to each other? For instance, I'm not sure about the best foundation. Is the slope shallow enough for a slab, or now we're, and I need a builder to tell me that, because I don't know. When do I get you guys talking to each other?
Right away. We've got builders that come to dome school. We've got builders that we talk to. I'm talking to some right now. And the dome in Colorado is going up, and Mark, the builder, Gary, the builder was here at dome school, and we talked before the plans were even finished.
Okay.
So
the sooner the better.
Sooner the better. Yeah, you don't want to leave him out, and he's going to say, oh, gee, you did this plan and it's wrong, and his suggestion is listened to by me. Yeah, I'm going to say, okay, what do you normally build out here, wherever it may be? What kind of soil is it? That's part of it, the slope. Do you do ICFs, which are insulated concrete forms for basement? Do you need a bit? It's all these different things that the builder's going to be the one to talk to.
Okay, thank you.
Sure.
Yeah. Okay. Charles from Washington. Which planning kit should be ordered to modify the interior of the mini dome? I do not need a full kitchen or a formal dining area.
Well, it's really taking the plan of the mini dome. So we don't really have an interior planning kit outside of the plan for the mini dome itself. So we can send you a copy of that plan that we created for the prototype that we have here. And with that, you can kind of modify that around, but we can do that together. Either we do Zoom calls, we'll just talk on the phone. You need to know the limitations that there may be. So what do you want to change and where do you want to put it? Make the stairway work. How big of a shower do you want? All those things can be talked about. And we do FaceTime, anything, any communication that you can have with us, we can do. And from that, help you make the decisions or help us redesign that plan for you, knowing what you want and why you want it.
Yes, thank you. I am a senior retiring, downsizing, so a lot of the stuff, for example, a full kitchen and service for 6 people wouldn't apply, where having a bedroom on the main floor would be more practical as I get older and can't get up those stairs. And I just didn't know where to start with, okay, these are my priorities, as opposed to what you have in your prototype.
Yeah, and the prototype is based on a 29-foot diameter dome. So the reality is that we've got somebody now looking at a 33-foot diameter dome done the same way, where we take that dome and we slice it, following the contour lines of the triangles of the dome. So that's something that we knew this could be done on a larger dome to get more space on the main floor. You could also add an extension on the back for a bedroom. That's plan hasn't been built, but it's been done. You can also talk about a chairlift. There's a lot of different ways to accomplish this, being able to stay in your dome and change as you change.
Thank you.
Sure.
Okay. All right, then Barry from Illinois, his question is, how big would a geodesic dome need to be diameter-wise to run an ADA compliant ramp parallel to the internal walls from the first story to the second?
I guess, sarcastically, I'll say a 74-foot diameter dome. But the reality is, yeah, depends on the wheelchair ramp specs that you want to use. You say ADA compliant. It used to be a 1 in 12 slope, 1 foot rise per 12 foot horizontal. The reality is they want to see 1 in 20. Now, can you get a wheelchair up in a 1 in 20 slope? Yes, you could. In a 1 in 12, you're going to work at it. And if your motorized wheelchair, maybe a 1 in 12 is what you want to do. But you're going to go, if you did an 8-foot ceiling with a 1 foot floor, you're going to go 9 feet. So now you've got basically 9 times 12, there it is, 108 linear feet. So it's 4 feet wide is what you really need because you're going to be on a curve. And the curve will not follow the outside of the, this is a good case here, the outside of the dome wall. Because when you get up to this point on your dome, you can't be right at the edge of that because you don't have the headroom. You have to move that in, and it's going to move in about 3 to 4 feet to get the headroom. At that point, you need 6'8". Now, you're in a wheelchair. Does that matter? Probably not. It's a ramp, but it's still an access going to the top. And if your building inspector's really sticky, he's going to say, well, I still need headroom up there, even if you say you're going to be in a wheelchair. Other people are going to walk up there and then have to bend over to get around that dome curve at the top. You're going to eat up a lot of space. That stair is going to go down all the way around. It's 108 feet long. If you did a 33-foot diameter dome, the circumference of your dome is 100 feet. You now wrapped that dome in a ramp. You blocked maybe your best view with a ramp. If you tried to do a 1 in 20 slope, you eat up the whole inside of your dome, and you probably came back on itself to try to do 1 in 20.
Right.
I think a cheaper alternative is to do a 1-story elevator. They're relatively inexpensive. You're going to spend lots of dollars to put the ramp in, eat up all this interior space, when you could do an elevator, and maybe that elevator is going to be $10,000, $12,000, $14,000. It's very simple. We've done them. There's some really nice ones out there. They're $40,000, $50,000, but you can get the basic elevator. And if you're planning for the future, like the previous person was saying, and wants to be able to live in this dome, we've done, here's your main floor closet, here's your upper floor closet, and it's a 4-foot, 3.5 to 4 foot square. And eventually you then put an elevator into it. But right now, for the time that you can get around and climb stairs, it's just a closet space.
Okay. How about, here's one that's probably would be answer a lot of people's questions possibly. This is, again, from Dave from California. Leaks, relative cost efficiency of usable space, general maintenance versus rectangular. Most of all, concerned about where I can build without local headaches from conservative codes, inspectors, and neighbors. So there's a handful of them for you.
Yeah, well, this is where when we switched from the first event that we had here to this is our second time, And we said, give us the basics of your questions. It worked out perfectly. I have answers. I wrote down answers to this so that I can come up with this realistic answer to all your questions. Domes leak. No, domes don't leak. People leak. It's the person that's building it. It's the person that didn't know how to build it. It's the experience level. It's the wrong material. It's bad details, bad design. You want somebody as experienced in doing a roof. You want somebody experienced in doing that outside. You want the right material. We don't recommend elastomeric coatings for the outside of the domes in cold climate, in a moist, cold climate, I'll put it that way, because it takes multiple coats, thin coats, to get this elastomeric coating on. So we're sitting in a dome that's been here for 13 years. We have dome tour. We had physical dome tours here twice a year. We have parties, we entertain. We have 8 domes on the property. They're open, you can walk through. Did we ever have leaks? Yeah, there's a few areas that we had, and we look at it and we go, what's the problem? Well, I know what the problem was. I built the dome in 1975 with about a 212 pitch on the roof, a very low slope roof. And we put a skylight in. And we didn't have the flashing systems that we now have. So one of the things that we have today, something we didn't really have a lot of, and this is a membrane waterproofing. So it's got a release paper on it. So you peel the release paper off, and it's sticky. It's aggressively sticky. So this is what you sometimes want. Other times, this is also a vapor barrier. So if you're doing foam insulation on the inside, we wouldn't recommend this on the outside of your plywood, because now you've got a foam on the inside, a vapor barrier, and then the outside, you put this underneath your shingles, and it's a vapor barrier. They trap the moisture in the plywood. So then you want a different covering. You want something that's breathable. So here you have deck armor. I'm promoting the one brand, but that's what it is, deck armor. That's going to give you breathable underlayment. So it's all of these things which relate to, do we know how to make a dome leak proof? Yes, we do. We learned a lot from the 70s. In the 80s, we got some new materials. In the 90s, we got more materials. Now we have building science. We know why a dome has condensation, why a house has condensation inside. We know you need to control your humidity levels. All of these things are part of it. So our domes don't leak. Most domes built today don't leak. There's issues with the builder. There's issues with the wrong materials. And then do we get callbacks from people that say, yes, my dome is leaking? Yeah, and what do? We go out and look at it, and we go, here, the nail popped out. Or the nail wasn't in all the way, it was put in at an angle. Or the wind came along and blew off some shingle because the shingle wasn't nailed on right. There's a reason for it. The collar around the vent pipe, all of these things have to be done right and not rely on caulking. So there's a whole series of things.
Right. It's just, I think it would be the same with any conventional home. I think it's just domes being available as kits encourage a lot of non-builders to build their own dome. And I've been into a lot of houses where the people built them themselves and they never built anything until their dome. So that was kind of where they learned all of their building techniques was on their home and their one and only major project. So I think a lot of domes more than conventional homes, because a lot of homeowners built their own homes with domes just because they do come in kits, you know, kind of resulted in a lot of people not knowing what they were doing. And the second part of his question was cost efficiency of usable space.
What you're dealing with in the dome is the upstairs space. If it's used for kids' bedrooms, they're using that all the way to the outside wall. You got 100% usage of that floor space. Your bed could fit there, chairs fit up against that outside wall. So the usable space inside that dome is actually, for the area that you're covering, it's a lot more than a conventional house. Can you use your attic? No, but you had to build it. So a conventional house with this attic space going has this huge area that if you don't insulate it right and ventilate it right is a problem, but it's unusable space. What we've done on a dome is blown away this attic and have this gorgeous volume of space inside. And then the next question people say, well, gee, it must cost a lot to heat all that air and do all this stuff. We're sitting in, like I said, the borderline of zone 7. We have 3,200 square feet of space, 2,100 square feet down here and 1,100 square feet up in this upper level. It's heated by the radiant floor that I'm standing on. There's no heat upstairs. It's right here. We have natural gas, and we are using, for the 10-year average, we're using $530. This is north central Minnesota, we'll call it. $530 is the total heating bill that we have. And that's talking about turning it on in October, usually mid-October, running through, and I kind of kid you, June. Always in May, we have heating that we still want. We do have a mini split system up above that we can turn the heat strip on, the heat pump system on from that. So we can turn it off in maybe April, early May. So the usable space thing about the dome is that it does use all of its space. The conventional house has attics, lean-tos, upper floors. I lived in a house that had knee walls on it. You couldn't use that space underneath that roof, but you had to pay for the building of it. So he's talking about meeting the codes, and we have one code in the US right now, and that is the International Residential Code. Real quick, this is the International Residential Code. That's how thick it is. So this is the code which is standard for the entire United States. There are variations. Some people add on to this in different areas, but this is what you're finding out. This is available. You can buy it. It's $150. Instead, we're looking at it. We know what's inside of it. We're going to design this for you to meet this code. Building inspectors may require you to have a licensed architect or engineer stamp and sign the plans. We can do that. Our engineer's out in California, but with his group of engineers, we've got registration in all 50 states. Do you want to be friends with the building inspector, or do you want to be his enemy? You want something that actually doesn't meet the code, it exceeds the code, and you want to show him how this exceeds the code, and we can do that. We talk directly to building inspectors. If they want something, if they don't understand something in the dome, we can talk to them about it. So that should not be a problem. They may ask for a certain detail. We've done it. We've been through there. We've been through the headaches of a really bad building inspector, but we satisfied it. There hasn't been one that has been turned down for not meeting the building code of ours. The other part of his question was neighbors. What about the neighbors? Well, if you're building in any kind of development that's controlled by a contractor, or it's got a homeowners association, and I tend to go by these and I call them Grageville. It's either gray or beige, and that's it. You can't do green on the roof. You can't change the siding. It's got to be this siding, horizontal, a lot of things that you don't want to have. And you're dealing with the neighbor. If you want to live in that area, why are you building a dome? So it's not the code that's going to stop this. And what we have found in all of these years that we've been building domes and putting them in all these different areas, including developments, including inner city lots. We have 2 or 3 in Minneapolis, 3 of them in St. Paul, in the city, on city lots. The neighbors go, what is this structure? They're interested in it. It's an interesting structure. So you're gonna have the neighbors coming into your house to see what the inside is like. They're gonna enjoy this thing. The same with the building inspector. He's gonna come back to say, okay, what are you doing now? Mine did. He came here every week. Said, okay, what are we up to? What are you doing? Talk to me about it. Not because he wanted to stop me, because he wanted to find out what we were thinking and how we were building it. So hopefully that kind of answers.
Yeah, yeah. And speaking of which, it's 7 o'clock and we still have some questions to get through. So for any of those of you who had a question but cannot stay on past 7, we do want to try to get to it, and we are going to try to make these videos available for people to watch later, either to hear answers to their questions again, or maybe they weren't able to make it because of a time conflict, but they wanted to jump in and hear some information. So hopefully if you are not able to be here for your question, you'll be able to access it later once we get a chance to get this posted or something. So let's see, Dennis, I got about 10 left actually. I'll try to get in a quick one here that I think a lot of.
One from Mike down in Texas is, I can answer that pretty quickly.
Okay, perfect. What would be the cost to upgrade a 30-foot low profile with 3 openings to a 40-foot?
That part of it, I'll deal with them over
Okay.
email on that
Back
part.
to the second part.
Yeah.
Can the heat reflective membrane be added to an airspace between the spaces and the insulation? What kind of increase in R value can be expected? I'm mainly concerned about heat transference. Temperatures will only drop below freezing a few times a year in my area.
He's down west of San Antonio, Texas. And you can add a heat reflective barrier, but here's the physics of it. You need, if this barrier is here, the sun's coming in, you need an airspace in front of this side of the outside where it's reflecting into. You need an airspace, 1 inch or so airspace. If you don't have that, if you put the wall, if you put this insulation, the radiant barrier insulation right up against that wall, it doesn't do anything. It can't reflect. That's the physics of it. How much R value does it add? Maybe 1, maybe a half, 0.6. That's all it's going to do. So it's not going to give you any increased R value, which is the resistance value of the material. Carrie, do you have the slide with the thermostat that shows, maybe you don't have that one already? That one, okay. So here's what we have. We have a thermostat upstairs. It has 3 temperature probes. The top one is the airspace. Now we have an 18-inch wall here. And I did this the other day with the outside temperature being a nice warm in Minnesota, 1 degree above 0. The airspace, there was a 2-inch airspace in there, 1.5 inch to 2-inch airspace, was 31 degrees. The next probe is in the middle of 16 inches of insulation. So what I'm saying is 8 inches in, it's 54 degrees, 53.9 degrees. So that's what the insulation did and the airspace. And the sun was shining, so it maybe, no, the sun wasn't shining. That's right. There was no sun out there. but the airspace had warmed up a 0-degree temperature to 31 degrees. 8 inches in from the insulation, if that's all the insulation you had was 8 inches, our value of about 30, 32, you'd have 54 degrees. So inside the inside layer of insulation on the surface, it's 69 degrees. And inside the house here, upstairs, it was about 70 or 71 degrees. So it was slightly cooler once you got on the other side of that wall, that paneling that we have. The reverse is true down in Texas. So what you got down in Texas was what we had up here was 95 degrees outside. The airspace was 164 degrees. That was the airspace temperature. 8 inches in was 110 degrees. And the surface temperature on the inside of the insulation was 74 degrees, which was the inside temperature of the air in the house. So that's the condition you're going to run up against down in Texas. Will a reflective barrier help? It probably will do something. So you can have that reflective barrier and that 1.5 inch airspace. But do we want to ventilate down in Texas? No. So there's the dichotomy of the whole thing. Do you really want to do that radiant barrier? I'm not sure it's going to help you. It's going to reflect it back through the plywood and through the outside. So radiant barriers as themselves as an insulator do nothing. There's no insulation value to it, really. And some people say there is, but there isn't. Physics will prove you otherwise.
Okay. Did you have any others you wanted to prioritize, or should I just kind of keep going down the list?
No, you can just
Okay.
pick some.
This one is John, and his question was, when estimating costs on an upper floor, does an extra bedroom cost less than the average square footage cost? In other words, if I go for a high profile instead of a low to get an extra bedroom, is that extra bedroom going to cost about, is that about what the average square footage cost is, or something less? I also wondered if the plans you develop show plumbing, wiring, HVAC, and other systems needed.
Sure. The value that you're adding into it is costing you less per square foot than you would, because the kitchen's the same and the bathroom's the same. Those are your big costs. You add a bedroom, it's raw space. So it isn't as much cost per square foot than the whole house cost per square foot. It's less cost. And it's adding a value to your house. You're adding another bedroom. That's a big deal from the value of your house. Do we provide plans for heating, ventilating, air conditioning? Yes, we do. We got a plan for that air-to-air exchanger. We got a plan for that heating system. The radiant floor is designed by a consultant that we use, Keith Kelly. And this is what he's been doing. He does it all the time. He draws out computerized drawing of the radiant floor heating layout and a list of materials. The one thing that we don't do is plumbing, the riser diagrams on plumbing. Derek, you know more about that. Maybe you could draw it up. I can't. I don't know enough about that to draw riser diagrams for the plumbing. Do you need it? No, you need a good plumber that can draw that out if the building inspector requires it. And usually they don't require it. Electrical plan, yes, we do that when it's required and when you want to. I'd rather have you deal, if it's not required for building code, I'd rather have you deal with the building electrician, guy who's going to put in that wiring there on the spot. So you can say, yeah, I want to switch here, there. I know I designed the system in here and I didn't really walk Tessa through it. So there's some light switches which he says, what does this one do? I said, well, it turns the light on over there. So then you got to turn it off somewhere. Well, there's an extra switch. So you got to plan all this out. You got to plan walking through your house. it's better to have your house there and the electrical guy there to show him, here's how it's going to work. And he'll tell you what the code requires you to do because he knows it.
Okay.
Derek, we have a question from John. He raised his hand.
Okay.
Talking about electrical stuff, is there a method to get electricity up on the inner surface of the dome shell itself? Say if you wanted to, do people put outlets up there or lights or things like that?
I can't tilt my computer up high enough here, but up on the very top near it's about 2 feet down from the edge of the cupola we have upstairs. There's a square box up there. That's a junction box for what I perceive when I find the time, and Tessa will agree with, designing this hanging light fixture up on the top, a sculpture basically. So I planned that out. There's a switch over here, and it's one of these switches with, what does this switch do? Well, it's for that outlet up on the top. How do you get there? We have some low voltage wiring that actually runs through the joints in the triangle panels. So that's a low voltage wiring. But on a 110 volt circuit, you need to be 1.5 inches back. Well, there's a line of struts. All these struts that we've got going up right here, you can go to the top of the dome, follow the strut line, staple it on the edge of the strut. And the inner 2x4 strut doesn't have a joint, doesn't have a connector on it. So you just keep going right straight up. You don't drill any holes. You just staple it along the inside and go to where you want it.
Yeah, if I could jump in quick, Dennis, I kind of feel like as far as electrical and plumbing go, it's the same as any other structure as far as, you know, how they build them in. I mean, they don't really do anything special for a dome necessarily. So the second floor on the dome, as far as wiring is concerned, would be the same as the second floor on any conventional home as well. And likewise with the plumbing, it just doesn't really, there's no special rules to follow. I mean, maybe the most complicated thing on the plumbing is if you need to put a vent from an exterior wall somewhere where it's got to kind of slope up the dome a little ways and come out. But for the most part, it's identical to any other home. So there's nothing complicated or more expensive or unique about it, really. So
You're looking here at some overhead lights right in here. They're can lights that are in the ceiling of the main floor. You need to plan those out, whatever you want to shine on. But I'm going to point out that you don't really want any can lights in your shell of the dome. Yes, we have LED lights these days, but you're actually, in most cases, breaking through a vapor barrier or an air barrier. You've got to seal that light fixture housing, and it can't let interior air get into the insulated space. So we try to stay away from all can lights that protrude into the insulation space of the dome. That's one of the things that we talk about. But this dome has, I believe, somewhere in the range of 90 electrical lighting outlets. So in the whole dome, that's a number that comes out of my head here just because I think I remember it. And these days, it's really easy to do electrical work because you're dealing with LED fixtures, low, extremely low wattage, and you can run more lights on that circuit.
actually, I got one more that's kind of related to what we're talking about, Dennis, that just popped in here. Would you say the same about plumbing as if we wanted to put in a fire suppression system? So.
Wait a minute, back up, what?
I said the plumbing is basically the same as it would be in any conventional home, and the same with electrical. And then they asked if they wanted to put a fire suppression system in, would I still make that statement about it being, you know, standard
No.
applications?
No. Reality is the dome is a lot easier than a conventional house. Conventional house, you're dealing with walls and a flat ceiling, and your sprinkler head is only going to cover so much. We've done this in the dome. And also, it's PEX tubing these days that supplies all of the fire suppression sprinklers in the dome. They're really easy to go right through this dome wall. We've got this very thick wall, and we put them to the inside. It's insulated. So you don't have, in our climate, you don't have a freeze problem. So you put a couple of sprinkler heads in here that really spread out. You need less sprinkler heads in the dome than you do in a conventional house. The other thing, and is this our last question, I guess?
No, I got a few more. That one just popped in while we were talking about plumbing, so.
So basically, I want to say, I say quickly, and Tessa looks at me. Yeah, I can't say it quickly. We're dealing with two different building fire marshals on some domes back in the 80s and 90s. They came to us and said, you know, they studied these domes and they feel this is so much better than a conventional house, because in a conventional house, 8-foot ceilings, and you have smoke, and that's the primary thing that causes death, is you can't get out of that house and you succumb to the smoke. In a dome, all that smoke goes to the top of the dome. Now, you don't crawl out of your dome, you run, because the smoke is going up to the top. And you can breathe and you can get out of your house fast.
Okay. This one's actually from somebody close by, Kristen from North Branch. She asked about humidity issues, designs, cost difference on insulation thickness. How far advanced should we plan? How far in advance should we plan?
I think we answered a couple of those questions there, but
Kind of did, yep.
the humidity level in the dome should be controlled. The first 2, 3 in a cold climate zone with your ceiling, I shouldn't say it. In every dome, we need an air-to-air exchanger. That's going to help control that inside humidity. In the south, you want to dehumidify that. Your air conditioner does it. In the wintertime, you may still have to dehumidify that house. In the northern climate, you may have to add a little bit of humidity to the house on the inside in the wintertime because it's going to get too dry. But the first 2, 3, 4 years of your house, this concrete slab that I'm standing on has 1,000 gallons or more of water that has to evaporate. And we said, your house is tight, it's sealed up. So you got to get rid of that. In the first 3 years, you have humidity issues, but you want to run a dehumidifier during the wintertime to get that humidity level under control. We're dealing with systems today, and I mean today, just in the last year or two with this COVID, where you got Trane and Lennox and Mitsubishi and all the companies are now coming out with a whole house system that's going to deal with humidity levels, air temperature, clean air, filters that are, the MERV rating is 16 or 20. So it's a different system today. You've got the appliances that are going to be able to control this inside level of heating and air that you're going to breathe.
Okay. I'm actually going to combine these last two because they're somewhat similar. It's Donna from Oregon and David from Michigan. Donna's question was how to get ready to build this spring/early summer. And David's question was how to collaborate to pre-design the opening. Can we share, handle a virtual 3D model? I guess they're both related to design and planning, so I'll throw those together.
Yeah. I mean, we're going to work with you on the design, and you got a 3D model or some sketch. We'll look at that plan, and I've been designing houses since the 5th grade, so that's what I like to do. But I want it to be your house. I've got ideas. I'll throw them out. I'll talk to you about different things that I would suggest. But if you've got a certain design that you want to try, show us. I'm working with somebody right now, an architect over in Israel, and his original design was, well, I'm taking this whole section of the dome out and making this open. And I go, well, you can't take the structure of the dome out unless you do this and this. So we're still working on that design. He's got an idea, and I'll say, it works, but you got to do this. We've got so many things that we don't even feature on our website that we've done. It helps from the standpoint of being able to say, well, I did that and I can show you, or I did that and it doesn't work, or it does work, maybe try this. But it's a collaborative thing that we're doing. We're not just coming back and saying, well, pick from this 8 designs or these 200 designs. Look at the designs that we have online. Does something fit what you want? I can almost guarantee you by the time you're done, you're going to make some changes because it was designed for somebody else on their site.
Okay, as far as sharing a 3D model, you can do that, I believe, right? So
Yes, yeah, we have AutoCAD systems here. We do have a consulting CAD drafter, I'll call him, Kim. And so if we need to do CAD drawings, 3D CAD drawings, we were doing that back in '92. So,
perfect. Well, I got the last 2. I'll kind of combine these as well. One of them, just because you're talking about removing part of the structure, was kind of a follow-up question with the mini dome. It says, I really don't understand how the mini dome works. Since the dome stands because of its intention, then you've cut all the support. So why doesn't it just collapse? Is that question. And then David had a question about what about natural insulation like cellulose, cork, etc. So insulation and a mini dome, a structure and insulation question, not really related, but those are the final 2, just in case those people are wondering if I was going to get to them. So.
you were here, Derek, when we put the mini dome up?
I actually was not, no.
You were not, okay.
No.
I was a little surprised. We put this dome shell up the day after Thanksgiving with friends and relatives. The framework of the dome was put up, the riser walls were put up, and then the framework was put up. And I was expecting the very top pentagon, which is actually cantilevered out, to go down a little bit. It didn't. We had already pre-designed and pre-built these wall sections that go up on the mini dome. They're straight vertical walls. We didn't change them to fit the dome because the dome had moved. We didn't raise them up to get them to fit. The dome has a shape. With our connection hardware system, it's locked in place and it doesn't move. It doesn't collapse. We learned this a long time ago. We open up a section of the dome. We don't brace it. There's somewhere, I can't tell you where it is on the website, but there's a dome in Duluth on the North Shore up from Duluth. And we came in and wasn't our original design, and the skylights weren't ours, and they had, right next to the water, they had rotted away. Sections of the dome were rotten. We opened the whole entire section. It was 3 riser walls wide, 2 rows of triangles high. We took it all out and then rebuilt using our component system, our connection hardware system, wedded into the one that was there. And Derek was involved in that project. And talk about that briefly. I'll throw it back to you and give you an answer.
Yeah, well, yeah, you're talking about the North Shore project?
Yeah, right.
Yeah, it's amazing domes. You know, you see a lot of people open them up to add extensions and stuff, so you know that there's certain areas that you can remove some of the struts and it doesn't really compromise the structure, but domes continue to surprise me on how strong they are and how you can remove parts of the dome without the dome sagging or shifting, where you don't see that really on any other, at least I've never seen on any other structure I've worked on in my construction experience. Usually, you know, if you're going to take away a part of a support, you got to reinforce that before you do that. With a dome, they're just very strong structures. Yeah, so I don't know. I think, did you get to the insulation question, Dennis? Natural options?
You know, we've tried different kinds of insulation. We tried the fabric, or blue jean really it's called, made from fabric. It's very hard to cut. It's very rigid. It doesn't really give you the ability to really fill in areas. The wool insulation, if you want to import it out of New Zealand, you probably can use that, but the insulation value isn't there. You're going to have a lot of it when you get into the areas where you need high insulation values. We do have a dome in Denmark. They have, I think it was, I don't know if Tessa remembers, they were thick walls, the one in Denmark with the seaweed. They were really thick. They're probably the 15-inch wall system that we have. They filled it with seaweed insulation. And it looks like noodles of spaghetti, you know, it's a crinkle cut noodle. And the seaweed was dried. They dragged it out of the ocean. This is northern Denmark, laid it out on the farm fields to dry it out, and then ran it through this machine. And as a dry, you know, it's like fiberglass insulation, basically. But there was a lot of airspace in there. That also helps insulate it, but it was very dense, and they packed those walls with seaweed insulation. People have mentioned straw bale construction. It doesn't work in a dome. You're dealing with triangles. You have to open that bale. You have to cut it. It's too loose. It has no body to it. In a straw bale house, you're relying on the fact that the bale is a bale, that's structure. And you build around that, and there's no supporting it by the hay bales. So if you want to try some other kind of insulation, we'd be happy to listen to what you want to try. And we can talk about, you know, we talked about foam insulation, and it's really, today there's less stuff involved in the foam. It's much more benign. So, yeah.
What about cellulose insulation, Dennis?
We have several domes that have blown cellulose and blown fiberglass into it. And we fill the air cavity. So you do an 18-inch wall, blow in cellulose insulation or fiberglass, blown fiberglass, and your R value is up there, and you'll be up to a 70 R value. It could be easy.
Okay. All right. Well, thank you, everybody, for sticking around with us a little later than our schedule. That seems to be our kind of norm around once
One
we
more
get
question?
talking.
Sure.
But if anybody wants to jump in with a question here.
This is John again. I know Natural Spaces from the website's been around almost 50 years. I want you to be around for 50 more years. So is there a plan for the continuity of the company? You'll surely want to put your drafting pencil down at some point, and who takes over?
When the casket is ready and I drop in there with my pencil in my hand. Derek, how old are you?
47.
Add 50. You're gonna be 97 years old. There you go.
Yeah.
I've got a 4-year-old grandson. He right now is just enamored with the domes. He calls himself a dome builder, a construction worker, and a dome builder. And he's got a tool outfit. He's got the hard hat. He's even got a light on the hard hat. I mean, he's just all decked out, and we're dying to have him get out here in the spring. We're going to put up another prototype and have him actually work on something as a 4.5-year-old. So, no, this will continue on, I'm sure. And the expertise that I have in designing the houses, well, there's about, I don't know, 1,200 different designs that we've done, and you can modify almost anything. Derek's had architectural background too. So, you know.
Okay.
We have a
Right here.
philosophy, and that's all part of it. And that's what attracted Derek. And I think that attracts all of our workers that we have. as you know, there are companies that are 100 years old. They've continued on. So this will too.
All right, thanks. Glad to hear it.
Yeah. Well, anybody else got any questions or comments or anything they'd like to add?
If I keep myself well, my dad lived to be 100, so I have something to look forward to, maybe get through this year or so here.
Right. Okay. Well, if nobody else has anything, I guess we'll,
No, we really want to thank everybody for the ones that are hanging on and the ones that are just listening in. This is what it's all about. We're trying to answer these questions for people that just want a quick answer and not go too far in depth, although I have in a few cases tonight. But trying to explain things to you. So we really enjoy talking to people, both Gary and I, although I monopolized the conversation tonight. But thank you, everybody.
all right, guys. Do you have anything, Carrie, you want to sign off with, or are we all wrapped up?
I think we're wrapped up. Just Happy New Year, everyone. Best wishes for 2021, and come back and see us for these talks and dome tours and dome school and everything that we're going to have going on in 2021 that will be in person soon, maybe.
Right. It's going to be.
All right, thanks.
All right.
All right, guys. Have a good night,
Good night.
everybody.
Good night.